Hello, ladies, gentlemen, and in between, and welcome to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today we're just going to go through some practice problems involving the first method of solving for the roots of a quadratic polynomial function, which is factorization. So let's get into examples quickly. Okay, so my boys, so this first example is we've got this function here, x squared minus 3x minus 10, and we're going to try and rewrite it as a product of two factors and then solve for its roots, remembering that the roots are the numbers where you chuck them into the function and you get an output of 0. So, sorry, knocked the tripod there. Right, let's try and do that. So recall our method from last time. All we have to do is look at these two things and think, well, the mystery numbers we're going to put into these linear factors, well, their sum must be -3 and their multiplication must be -10. And if you do some thinking for a second, well, we can try out different examples like, multiplies to -10, or about 10 and -1. Well, their sum doesn't work. Well, the only other option is 5 and 2. And if we have -5 and +2, those will indeed multiply to -10 and they'll sum to -3. So we know we need to put a -5 and a +2 in these linear factors. And there we've successfully rewritten this function. This is the exact same function still, we've just rewritten it in a different way, which makes it a lot more convenient now. If we set it equal to 0 to solve for the roots, we can just look at both of these factors individually. So from this factor we can deduce that, well, x minus 5 must equal 0, so x must equal 5. And from this one, we can get x equals -2. And my boys, it's really that simple. It's kind of scary how not that difficult it is to get to instantly find the roots of a quadratic polynomial. Now, let's get into the next one. Okay, so my boys, this is going to be a bit of a harder example. If we look at what this question is, well, we've been given two functions this time. We're given two functions. One of them is a quadratic polynomial, one of them is a linear polynomial, and we're asked to solve f of x equals g of x. Now, what that means is solve for the input x such that this function and this function happen to output the same value. So if we can rewrite this, we know that this function acts on the number x, well, that's the same thing as taking x squared minus 10x plus 10. So that's the function acting on our number x we're trying to figure out. And then we want that to be equal to when you take 3 times x minus 2. Now, this might not look like a factorization problem at first glance, but trust me, it is, and you'll see why. Now, remember, if we want factorization to be useful, we need to set it equal to 0 eventually. So let's try and have 0 on this side and see what happens. So if we subtract 3x and then add 2, we're going to get x squared minus 13x plus 12 equals 0. So we've rearranged and found this is another condition that our mystery number x must fulfill if we're going to want the x put in through f and x put through g to be equal to the same thing. And now, my boys, we can try and use factorization on this thing. So we're going to try and write it as x times something times x times another thing. And now we just have to think, well, what two numbers, when you add them, you get a minus 13, and then when you sum them, you get 12. And if you do some little brain power right here, well, you can think, well, 6 and 2, not really a way to get those to -13, even though they will get 12. And the only really other option is 12 and 1. And if we have -12 and -1, then indeed those will sum to -13 and they'll multiply to +12. So we know that these numbers we should put here are -12 and -1. So we've rewritten this as a product of two factors. We can set it equal to 0 and we find that, well, x must be equal to 12 or x must be equal to 1. So we found the two values of x such that this function and g of x, if you plug x into them, they output the same thing. And you can check that real quick. For example, if we use x equals 1, because there's a lot easier number to work with. If we chuck in 1 here, we're going to get, well, f of 1 is 1 minus 10 plus 10, which is just 1. So f of 1 equals 1. And if we plug in 1 here, we're going to get 3 times 1 minus 2, which, boys, equals 1. So this does indeed satisfy the property that f of 1 equals g of 1, which is f of x equals g of x. So that's brilliant. Now let's do a harder one, boys. Okay, my boys, right, this one is going to be a lot harder because we've got a 2 in front of this x squared here. And you remember that when we've got a not 1 in front of the x squared, it becomes a little harder because factorization, right? And the question is to just solve f of what number equals 0, which is just a complicated way of saying let's find the roots of this quadratic polynomial, right? So let's set up the factorization. So we want this function to be rewritten as 2x plus something times x times another thing. And if you recall, we need to put this 2x here and this x here because we want these two functions to be the same. This is what we're writing down here. And that can't happen if we've just got an x and an x here. So remember that. If you don't really know why that is, you can always watch my last video. So now let's use the peanut method as I introduced last time. So we're going to want 2 times something and 1 times something. We want that's going to equal some other thing. And we want that sum to be equal to positive 1. And we want these two mystery numbers to multiply to negative 6. Okay, so let's think about it. What are the factors of 6? Well, 3 and 2, that looks kind of promising here, right? So let's try it. So if we have negative 3 here and 2 here, we're going to get negative 6 plus 2. That's not going to work. Okay, let's try 2 and negative 3. And yeah, that does work. If we have 2 here and negative 3 here, we're going to get 4 on this side, and we're going to get negative 3 here, and they'll sum to 1. So to just complete the thing, we're going to cross, and we say, okay, well this 2 pairs with this negative 3, so that means we have 2x paired with negative 3, and we do the other cross here, and we're going to see that this 1x here is paired with the positive 2. And by the way, the reason I call it the peanut allergy is because those kind of look like peanuts. I used to call it something a bit more devious, but this is a family-friendly channel. Anyway, right? Anyway, sorry. If I just grab my rubber. So, boom, we successfully rewritten this terrible quadratic polynomial as a product of two factors. I probably didn't point in the right place there, but you know, who cares? Anyway, and now if we set it equal to 0 to find the roots, so to satisfy this equation, we're going to see, okay, well, 2x minus 3 equals 0, or x plus 2 equals 0. And then it's not hard to see from this one that x must equal 3 halves, or from this one, x equals negative 2. So boom, we found the roots to this quadratic using factorization. Now, isn't that just sublime? Okay, now I'm sorry to leave you so soon, my boys, but that is going to end this video. And I hope you've got some lovely questions to do here, and I'm going to leave you on a problem to do on your own. And I hope this video has been helpful. Thanks, my boys. Remember to smash that like button, smash that subscribe button for your appreciation for your boy Hamblin. Right, so thanks for watching, and I'll leave you with that problem.